Hello guys, my name is Izhaan, and currently I'm pursuing my degree in Civil and Environmental Engineering from IIT Patna. In the previous session, we were solving the exemplar questions of the topic communication system, and we had done the question number till 16th, I guess, and then we had to start, no, till 17th we had done, and now from question number 18th we have to start now. Okay. So this is an kind of important topic for the mains perspective because uh, usually one question will come. Sometimes it can be two, but like it is an easy question. It is a solvable one. So if you put in 2 or 3 hours on this topic, then it will be fruitful for you. You'll get 4 to 8 marks extra in your mains exam. So that's it for this. And now starting from question number 18. So the maximum amplitude of an AM wave is found to be 15 volt. So A max, we know it is 15 volt, while its amplitude minimum is 3 volt. And what is the modulation index? So what is the formula for modulation index? Mu is equals to A max minus A min whole divided by A max plus A min. See, this topic is basically it consists of 5 or 6 topics, and they all are easy topics. They are all just formula based. Like this, this is a question. This such kind of questions can come in the exam, so it is not a big thing. Like you say that it's a formula based question, it can come. So you just have to calculate modulation index. So 15 minus 3 divided by 15 plus 3. So that leaves us with 12 by 18, and that is 2 by 3 or 8. So that is the modulation index for this condition. Now, question number 19. Compute LC product of a tuned amplifier circuit required to generate a carrier wave of 1 megahertz for amplitude modulation. Okay, we have to find the LC product already. So we already know that mu is equals to 1 upon 2 pi under root LC. Alright. Then, as per the question, angle that has been given to us is 1 megahertz, that is equals to 10 to the power of 6 hertz. Then we can write LC as 1 upon 4 pi square 10 to the power of 6 square, and that will be equal to 1 divided by 2 pi square into 10 to the power of 12 leaves me with it is 5.06 10 to the power of minus 14 seconds. Alright. Hopping on to the next question. Why is an AM signal likely to be more noisy than an FM signal upon transmission through a channel? Okay, so this is a conceptual question. Alright. And I'll just tell you the reason why it happens. So in an AM signal, it is likely to be more noisy than the FM signal because through a channel, when the instantaneous voltage of the carrier waves is varied by the modulation wave voltage, so during the transmission, noise signal can be added and receiver assumes that noise is the part of the modulation signal. See, this is a channel. Okay, and this is your desired signal. Desired signal, and this is your noise. Okay, it goes through the same channel. So what happens is when we talk about AM, then noise and desired plus desired. You cannot tell them apart. All right. They basically the consumer thinks both are uh, a one unit. Both are one unit. So that makes it like more noisy. Alright. But in case of FM, the frequency of the carrier wave is changed as the change in the instantaneous voltage of the modulation wave. Now, this can be done like you can do this when you mix, and while the signal transmitting channel in the noise should be heard differently than the desired voice. Like same thing. There's a channel, there is desired, there is noise. Alright, both have their noise as well as desired. But what happens here is noise is heard differently and desired sound is heard differently. FM. This happens in FM. So, like the important point is this, that in frequency modulation, that is inversely proportional to the modulation frequency FM. So while in PM it does not vary with modulation frequency, so FM is more noise immune, you can say. All right. Question number 21st. Now it shows a communication system. What is the output power when input signal of 1.01 milliwatt? Okay, so gain decibel is also given to us all later. So, okay, so transmission path, first of all. Transmission. So पहले आएगा transmission path की दूरी है 5 kilometers. Right. Loss suffered in transmission path. The loss suffered that is equals to कितना -2 decibel per kilometer है ना, तो -2 decibel per kilometer और कितनी लेंथ है 5 किलोमीटर. So the loss that has been suffered is -10 dB. Alright. Now amplifier gain कितना होगा? Total amp gain 10 plus 20 is equals to 30 dB. Okay. Over gain of signal. Thirty minus 10. It is 20 dB. Now, this 20 is equals to 10 log base 10 P naught by PT. Alright. And this can be written as P naught by PT 10 का whole square, यानी 100. Then P naught is equals to 100 PT. Alright. P naught is equals to 100 PT. 100 and PT is given as what? 1.01 milli into 1.01 milliwatt. Then it will be 101 milliwatt. Okay, so let's read our next question. So a TV transmission tower antenna is at a height of 20 meters. How much surface area can it cover if the receiving antenna is at ground level? That is the part. So we just go on with this first. I never like what my take will be. I'll tell you one thing. In the means, for the means perspective, most of the time, like 6 or 7 out of 10, you can say that if you just remember the formula and you know what are the values that you have to put in those formulas, you'll get the correct answer. But those 2-3 questions that come, alright, in those questions there's a twitch. There's something that they have changed. What happens is you like most of you will ignore the derivation. Okay, that is a very big mistake, and that does not happen when you go for mains question. That is a major problem when people go for the advanced questions. So what happens is they will tweak the problem in such a manner that you think that the basic formula will work for you. But when the formula is derived, okay, and some conditions are considered already, and those conditions when are tweaked, then the derivation will change. All right. Suppose if I I can't give you any example right now, but you just have to listen to me. Okay, that is what I'm saying. So if you okay, I'll tell you one. There's a formula E plus F upon 1 minus EF equal to V square upon RG. Okay, this is a super elevation formula. When the road is elevated through an angle theta, then this tan theta is called an E. Okay, so in derivation, we derive this, but since E is the super elevation and F is the friction, so product of EF is much less than 1. So we ignore this part and we write E plus F is equals to V square upon RG. You'll remember this formula for means perspective. Now, I'll tell you what the question will come in the JE Advance. So the JE Advance will tell you that there is a race track. Okay, there is a race track and there is a Formula One race track, and the super elevation E or the theta is equals to 30 degree, 40 degree, 45 degree. Now, what will happen in this case? Tan theta, that is E, will have some like significant value. Okay, this will not be very small. It will have a significant value. And also, if it is a racing track, then it will have much greater friction than we have in the long road. So F will also be large. And the product EF will not be much less than that. Okay, EF will be comparable to 1. And in that case, if you apply this formula, you get the wrong answer. And if it is a question of objective type, they'll give you the option in which the answer will come through this formula, and that will be the wrong one, and you'll get a -2. So if you know the derivation, if you know that what you have done in the derivation, what things have you assumed, and what conditions have been changed over here, then it will be easy for you. So in this case, if EF is not very less than 1, E plus F upon 1 minus EF will be considered is equal to V square upon RG. So this is the formula for super elevation. Okay, so that is what I'm trying to tell you. Alright, that derivation is very important. Alright, and even like I'm not telling you to derive the formula every time you try to solve a question, but if you know the gist of this topic, then gist of the derivation, then it will be easy for you. Like this question over here, I never memorized the formula for this. It was a simple derivation. See, this is the radius of Earth. Okay. Is it a height of? Let's say this is the height. Now it can go till where? Till this point. Okay, then the curvature is going like this, and this point is tangent. Alright. So R, and since this is the point of tangency, it will join the line between the center at a 90 degrees angle. Alright. And this is the distance that it can cover. Alright. So R plus H square whole square is equals to R square plus D square. Now R square plus H square plus 2RH is equals to R square plus D square. Alright. Since this 2RH is much greater than 2RH is much greater than H square, then we say that 2RH is equals to D square and D will be equal to under root 2RH. So this is an assumption. We have assumed that this value is very small, so we have ignored it. Sometimes it can be large. Sometimes they can say that the length of the antenna is impractically 20 kilometers. And you'll consider this. Right now it is 20 meters. So why bother? So D is equals to root 2RH. Alright. No. So how much surface area can it cover if the receiving antenna is at the ground? So that is the question in the. So the range will be 2RH and root 2RH. We've already seen this in the 2RH, and then we'll calculate it and we'll get the value. Number second is at a height of 20 meters. So that is an H dash like this. H is equal to 20 meters. And for the second part, it will be under 2RH plus under 2RH dash, where H dash is equal to 5 meters. Alright. Now, if you want to get like, find the change in percentage, it will be 2RH dash upon under 2RH multiplied with 100 2 r तो चला ही जाएगा. It will be whole under root of h dash upon h into 100. तो I can write it as h dash है 5 और h into 1/4. 1/4 is 50. Now question number 23. So if the whole earth is to be connected by LOS communication using space waves, alright, no restriction of antenna size or tower height. What is the minimum number of antennas that are required? Calculate the tower height of these antennas in terms of Earth's radius. Alright. So first of all, the key concept behind this you need to know. Right over Key concept. Key concept is that the distance of range of transmission I've already proved that it is under root 2RH. Alright. Where R is the radius of Earth. R की value you should know 6400 kilometers. That is the radius of Earth. Alright. HT is the height of transmission tower. Height of transmission tower. Alright. Now let us consider the figure. Okay, so no figure is given over it. Now let's assume that the height of the transmitting antenna or the receiving antenna in order to cover the entire surface of the earth is h1. Okay, let's suppose it is h1. So, and the radius of earth is r. And dm is the line of distance between like both two antennas. So dm per square will be equal to 2r plus ht per whole square. Alright. So r ht is equals to r square plus ht per square plus 2r ht. Now r minus ht per whole square is equals to 0. R is equals to height of transmission tower. So you got this now? How did we come from here to here? It will be r square plus ht square minus 2rht. Then we can write it as r minus ht whole square. This will be equal to 0. So r will be equal to ht. That means the height of transmitting tower will be equal to the radius of the earth. Alright. Okay. So next question is question number 24. The maximum frequency for reflection of sky wave from a certain layer of the atmosphere is found to be F max is equals to 9 n max under root, where n max is the maximum electron density at that layer of the atmosphere. On a certain date, it is observed that signals of frequencies higher than 5 MHz are not received by reflection from the F1 layer of the atmosphere, while signals of frequencies higher than 8 MHz are not received by reflection from the F2 layer of the atmosphere. Estimate the maximum electron density of the F1 and F2 layers. Very simple question, but the language of this question is kind of difficult. So you need to understand this question first. They are telling you the maximum frequency of reflection of sky wave from a certain layer of the atmosphere is found to be. See, I'm talking about the frequency. Okay, this is the ionosphere. Ionosphere. And the like hits it, comes back. Then this maximum frequency, F max. Frequency maximum which is reflected back by the ionosphere is equals to 9 times electron density n max divided p power 1/2. And n max is the maximum electron density at that layer. If it is getting reflected from layer 1, then this will be n max of layer 1. Maximum electron density of the layer which is reflecting back the frequency is this formula is satisfying those conditions. Only now, on a certain date, it is observed that signals of frequencies higher than 5 MHz are not received by reflection from the F1 layer. Okay, of the ionosphere, while signals of frequencies higher than 8 are not received by reflection from the F2 layer of the ionosphere. Estimate the frequency maximum electron density of the F1 and F2 layers. Simple question again. You know that for layer 1 and layer 2, what is the maximum frequencies? Okay. So for layer 1, F1 will, max will be F1 max, and for layer 2, there will be F2 max. Okay, then you have to tell the ratio of the electron density maximum for one layer and two layers so that you will divide this. Simple. So now my F1 max divided by my F2 max will be equal to what? N1 max divided by N2 max the power 1 by 2. Simple. Now F1 upon F2 का जो अच्छा हम लोग को अलग अलग निकालेंगे, रेशियो नहीं निकालना, अलग अलग निकालना. ओके, तो अगर अलग अलग निकालना है तो वैल्यूज पुट कर देंगे. तो फॉर F1 layer it was 5 megahertz maximum frequency. So 5 into 10 raised to the power of 6 is equal to 9 n max the power 1 by 2. ये for layer 1. for layer 1 है, ठीक है. तो इसको कैलकुलेट करेंगे. 5 into 10 is to the power of 6 divided by 9 answer है, and the root is 740 square. 3.08 into 10 raised to the power of 11. So my value for n max for layer 1 is equals to 3.08 into 10 raised to the power of 11. Similarly for layer 2, the maximum frequency that is there is 8 megahertz. Now you know what we are doing at n max. ये कोई फॉर्मूला आपको पढ़ाया नहीं है. This formula has been given in the question itself, and you just have to find the values. You just have to put in the correct values in it. So 8 into 10 is to the power of 6 divided by 9. Answer का square. That will be 7.9 into 10 is to the power of 11. So n max for layer number 2 will be 7.90 into 10 is to the power of 11. So that is the electron density. Alright, hopping on to the next question, question number 25. So on radiated and AM modulated signal, the total radiated power is due to energy carried by WC, WC minus WN, and WC plus WN. So suggest ways to minimize cost of radiation without compromising info. So sideband frequencies, that is the concept behind this question. Sideband frequency, I have already told you, like the AM wave will contain 3 frequencies, right? If there is an AM wave, then it will contain 1, 2, and 3. So 1 will be WC minus WM, WC. This is the carrier omega, this is the omega for the modulating. WC plus WM. Alright. Now these two are the sideband frequencies. Sideband frequencies. This is the upper sideband. This upper sideband. This is the lower sideband. Alright. Now sideband frequencies are generally they are close to the carrier frequency. Only sideband frequencies contain info in amplitude modulated signal. Alright, so in amplitude modulated signal में केवल जो sideband है WC minus WM and WC plus WM, they will carry the info. Alright. Now, and the total radiated power will be due to the energy carried by these say for reduction of cost radiation without compromising on info. WC can be left and transmitting the frequencies, only these frequencies will be transmitted and this will be left out. Okay, so this will minimize cost of radiation and it will not compromise any loss in info. So now moving on to the long answer type of questions. The intensity of light pulse traveling along a communication channel decreases exponentially with distance x according to the relation that has been given to us. Alright. where I naught is the intensity at x equal to 0 and alpha is the attenuation constant. Show that the intensity is reduced by 75% after a distance of ln4 by alpha. Alright. So what has been given to us? So intensity I is equals to I naught e raised to the power of minus alpha x, where I naught is the intensity at x is equals to 0 and alpha will be the attenuation constant and this is x. Okay, so we know all of the values over it. Now, if I want to write, I can write it like this. Sorry for the bad name. I divided by I naught is equals to e raised to the power of minus alpha x. Alright, now I can take log over here. Should I use so log ln? So ln I upon I naught is equals to minus alpha x, and ln I naught upon I is equals to alpha x. Alright, now at x is equals to ln 4 by alpha. So if I put the value for it, ln I naught upon I is equals to alpha ln 4 a whole upon alpha चला गया. Alright, so ln I naught upon I is equals to ln 4. That means that I naught upon I is equals to 4. Alright, simple. Percentage decrease in intensity का मैंने निकालना है. यहाँ से मुझे वैल्यू दी गई I naught is equals to 4 times of I. Okay, now if you want to calculate the decrease in intensity equal to what? I naught minus I upon I naught multiplied with the 100. And that will be what? If you can write it as 1 minus I upon I naught. So I upon I naught will be 1 upon 4. So it will be 3 by 4 times 100. That will be basically 75%. Now the attenuation of a signal can be expressed in decibel according to the relation dB equal to 10 log base 10 I upon I naught. What is the attenuation in dB per kilometer for an optical fiber in which the intensity falls by 50% over a distance of 50 kilometers? Alright, so the second part of this question is attenuation constant of a signal is expressed in decibel form. Alright, according to the relation has been given to us. So what is the attenuation in dB per kilometer for an optical fiber in which the intensity falls by 50%? Okay, got it. So if I let the attenuation be alpha in decibel per kilometer, okay. So if x is the distance traveled, then 10 log 10 log to the base 10 I upon I naught is equals to minus alpha x, and it has been given to me that I upon I naught is equals to 1 upon 2, x is equals to 50 kilometers. Then 10 log 10 I upon I naught value 1 upon 2 is equals to minus alpha into 50. Okay, I can write 10 log 10 2 is equals to 50 alpha. Okay. 5 alpha is equals to log base 10 2. Okay. And I can write alpha is equals to 1 upon 5 log to the base 10 2. This will be 0.3010 divided by 5. And that will be how much? If you want to calculate, it will be 0.0602 decibel per kilometers. Okay, so next question is question number 27. A 50 megahertz skywave takes 4.04 milliseconds to reach a receiver via retransmission from a satellite. Okay, so 50 megahertz skywave, it will take 4.04 milliseconds to reach a receiver via transmission from a satellite 600 km above Earth's surface. Now, assuming retransmission time by satellite negligible, find the distance between source and receiver. If communication between the two was to be done by LOS method, what should size and placement of receiving and transmitting antenna? Mark this question important. Okay, question number 27 is an important question. So what happens in this is, let the receiver, like I'll draw a diagram for you first. This is the transmission. This height. This is the height of the tire HT. This is the X and this is the T. Okay. And 2x upon time. आने जाने की दूरी is equals to velocity. We know the velocity already. 3 into 10 is to the power of 8 meters per second into 4.04 into 10 is to the power of -3 seconds. Alright. तो यहाँ से मैं अगर x कैलकुलेट करना चाहूँ तो 2.02 ओके तो 6.06 आएगा हमको. तो x की वैल्यू आएगी 6.06 into 10 is to the power of 5 meters. Alright. Now that is equal to 6 kilometer. Right. Now the diagram that I drew for you, d square is equals to x square minus ht the whole square. 606 का square minus ht कितना है? कौन सा relate 600 किलोमीटर तो 600 minus 600 का whole square. That will be how much? That will be 600 square minus 600 square. 7236. 7236 will be d square or d will be under root of 85.06. 85.06. So this is the distance that it will travel. Alright. Now distance between the source and receiver is 2d. Alright. तुमको d पता चल गया है. This is the height of satellite HS. ये इतना है डिस्टेंस टी, इतना फिर से डिस्टेंस टी. टोटल डिस्टेंस इज 2d. नाउ 2d को मैं कह दूंगा 170 किलोमीटर अप्रोक्सीमेटली 85.06 है d. ओके. नाउ इफ आई वांट टू फाइंड द dn it will be 2 times 2rht. ओके. तो 4d square is equal to 8rht and d square upon 2r is equals to ht. d square की वैल्यू पता है 7236 upon 2 into 6400. 7236 divided by 6400 divided by 2. So it will be 0.565 kilometers. So that will be 565.3 meters. Alright. Okay, so next question is question number 28. So an amplitude modulated wave is shown in the figure. Calculate the percentage modulation. First of all, peak carrier voltage and peak value of information voltage. Okay, so from the figure, we can see that the Vmax is how much? That is 100 volts. So Vmax will be 100 by 250 volt. Right? Vmax पूरा base से ऊपर रखा है. तो Vmax will be 100 by 2. समझ गए ना? Why are we dividing it by 2? Because the distance between the topmost and bottommost point is 100. So Vmax will be 100 by 2. It is equals to 50 volts. And now calculate Vmin. Vmin will be how much? The data has been given that 20 is the minimum from the bottom to the top. So it will be 20 by 2. That is equals to 10 volts. Only. Now percentage modulation. Number one, modulation the formula like we had done just now. It will be Vmax minus Vmin upon Vmax plus Vmin. Alright. Vmax minus Vmin will be 50 minus 10, 50 plus 10, 40 by 60, 2 by 3. Alright. 2 by 3. Multiplied by 100, you'll get a 66.67%. And now number 2, that is peak carrier voltage. Peak carrier voltage VC will be V max plus V min divided by a 2. So that will be 50 plus 10 by 2, that is equal to 30 volts. Alright, now number third, peak info voltage. Peak information voltage is Vm is equals to mu Vc, that is equal to 2 by 3 into 30 till 10. 2 into 10 is 20 volt. Okay, now next question. Draw the plot of amplitude versus omega for an amplitude modulated wave whose carrier wave WC is carrying two modulating signals, W1 and W2. Okay, so let's see. Okay, so it is a lengthy question on it, so I'll try to do as soon as possible. So frequency VT, you can address a amplitude modulation 1 sine omega m1 t plus amplitude modulation 2 sine omega m 2t, okay, plus AC sine omega ct. This A plus B, A m1 sine omega m1 t plus m2 sine omega m2 t plus AC sine omega ct. ठीक है, इसका होल स्क्वायर. Now I can go on and write the same. Like I'll say that this is my A dash, alright, and this is I'll change this a bit. Then A dash, I can just link it up together. Give this A dash. So आगे बोलूँगा B A m1 sine omega m1 t plus A m2 t का होल स्क्वायर प्लस AC का स्क्वायर साइन स्क्वायर ओमेगा ct साइन स्क्वायर ओमेगा ct plus 2AC A m1 sine omega m1 t plus A m2 sine omega ct. Alright, and moving onwards, B के लिए हो गया. Then A m1 sine omega m1 t plus A m2 sine omega m2 t plus AC sine omega ct फिर से sine omega ct. और B के लिए तो चेंजेस आ रहे हैं. B am1 का स्क्वायर साइन स्क्वायर ओमेगा m1 t plus amplitude modulation 2 का स्क्वायर साइन स्क्वायर फॉर ओमेगा m2 t और प्लस 2 टाइम्स am1 am2 साइन ओमेगा m1 प्लस प्लस ओमेगा नहीं साइन ओमेगा m1 t साइन ओमेगा m2 t into साइन omega m2 t. Already. Now if I want to write it, okay, if I want to write it, A m1 sine omega m1 t plus A m2 sine omega m2 t plus AC sine omega ct. You already know. Plus B times A m1 का स्क्वायर साइन स्क्वायर ओमेगा m1 का t plus A m2 का स्क्वायर साइन स्क्वायर ओमेगा m2 का t and then AC का स्क्वायर साइन स्क्वायर ओमेगा ct. Okay, now plus 2 A m1 A m2 divided by 2 कट जाएगा and साइन वाला फॉर्मूला अगर खोल के लिख देंगे तो cos ओमेगा c माइनस ओमेगा m1 t, ठीक है, माइनस कॉस ओमेगा c प्लस ओमेगा m1 t, ठीक है. तो नेक्स्ट अब फिर से यहाँ पे आ जाएगा प्लस 2 ACAM1 divided by 2, और यहाँ पे आ जाएगा cos omega c minus omega m1 t minus cos omega c minus plus omega m1 t ACAM1 cos omega c minus omega m2 t minus cos omega c plus omega m2 t. There's a 2 to the diagonal, and that will be the final derivation. And the excuse me. So the frequencies that are present are omega m1, omega m2, and carrier frequency omega c, omega m2 minus omega m1. We are just taking the different frequencies that we have in the sine or cos form, right? Omega m1 plus omega m2. Again, omega c minus omega m1, omega c plus omega m1, omega c minus omega m2, omega c plus omega m2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 different frequencies are there. Now, if you want to plot the amplitude versus WS, then it will be what? If you want to plot the amplitude, so the first of all, I have WM1, okay, WM2, WM2 minus WM1. Next will be WM1 plus WM2. Next is WC minus WM2. And here will be WC minus WI. Then will be plus WC. First for WC plus WM. WM1 और उसके बाद आएगा लास्ट में over here WC plus WM2. So the part 2 of the question was what? Part 2 is the plot symmetrically about WC. Okay, yeah. So it can be seen that the frequency spectrum will not be symmetrical about WC. Routing of the spectrum will be present somewhere, like in the starting part WM1, and between WM1 and WM2, there was WM2 minus WL1 was also there. So routing will be there. It will not be symmetric about WLC. Now, what is the third? Extrapolating to take the problem, one can expect if more waves are to be modulated. Adding more modulating signals will lead to more crowding. Like we have seen now, it is first of all it is not symmetric about WC. There is crowding between WM1 and WM2. So if you increase the number of modulating signals, then it will generate more crowding, and chances of mixing the signals will be more. So that will be a problem. Now suggest solutions to the above problem in the process. Can one understand another advantage of modulating in terms of bandwidth? So increasing bandwidth in WC to accommodate more signals, that will be helpful. Now this shows that large carrier frequencies are able to carry more info, more WM, and which will in turn increase the bandwidth. So if you increase the bandwidth, then you will be able to transport more signals. Again. Okay, so the last question. An audio signal is modulated by a carrier wave of 20 megahertz. Okay, such that the bandwidth required for modulating is 3 kilohertz. Could this wave be demodulated by a diode detector which has the values of R and C as such? So frequency of modulation FM is 1.5 kilohertz. Okay. Now, if I want to calculate 1 upon FM, that will be how much? 1 divided by 1500. That will be 0.666 into 10 to the power of minus 3. Then I can extract 0.7 second. Okay. Now, part 1. If I want to calculate the RC for the part 1, that will be 10 to the power of 3 into how much 10 is to the power of minus 8. So it is equal to 10 is to the power of minus 5 seconds. So what I've seen that 1 upon FC is much less than RC. Okay, that is much less than 1 upon FM. This is satisfied. This set is satisfied. So this wave can be modulated. Now moving on to the next one. So in the next one, question number second, RC is equal to 10 to the power of 4 into 10 to the power of minus 8. So that will go to 10 is to the power of minus 4 seconds. Here to 1 upon FC will be much less than RC, much less than 1 upon FM. So this can be demodulated. Now the last option is RC is equal to 104 into 10 to the power of minus 12. So minus 8 seconds. Now here 1 upon FC is greater than RC. So cannot be demodulated. Alright. So here we conclude this topic on communication systems. Alright. Now I'll get some PYQs for this topic and we'll solve them. Alright. So just give me a minute. Okay, so the first question is I'll write in the short form and dictate it to you. So, what should be the height of transmitting antenna if the TV telecast is to cover a radius? Of 128 kilometers. You have to tell the height of the antenna. Alright. Now, radius of Earth you already know. If the average population density around the tower is 1000 kilometers per square, how much population is covered? Alright. If the average population density is equals to 1000 per kilometer square, then how much population will be covered in this? How much population covered? This is the question. Now, the height of the transmitting antenna, if you want to find out, it will be h is equal to d square upon 2r. Alright. Now this will be 128 into 10 to the power of 3. That is the radius of coverage given to us. Square all divided by 2. Radius over the now that is 6400 kilometers. Alright. That will be 6400 kilometers. So 6400 into 10 to the power of 3. Now, if you want to calculate this, how much will it be? It will be 128 into 10 to the power of 3, the whole square divided by 2 divided by 6400 or 3 to 1280 into the power of 80 meters. 1280 meters is the height of the antenna. Now, the total population covered will be pi d square into population density. Simple. So pi 128 the whole square into 1000. Sure. It will be 5.14 into 10 to the power of 7. So, okay. Move on to the next question. Okay, so I'm going to frequency reflecting back another. So I'll use a single question. So write the question. In short wave communication, In short communication, which of the following frequencies the following frequencies will be reflected okay by the ionospheric layer having electron density N is equal to 10 to the power of 11 per meter cube. Alright, and I'll give you the options 2 megahertz, 10 megahertz, 12, and option D will be 18 megahertz. Okay, so try it yourself and then see the solution. For it, I'll give you just simply write this formula 9 n max to power of 1 by 2. This was the formula, right? And this was FC max. तो मतलब इसके नीचे जितनी आएंगी सारी रिफ्लेक्ट हो जाएंगी, लेकिन इसके आगे जितनी आएंगी वो रिफ्लेक्ट नहीं हो पाएंगी. ऑलराइट. Okay, so calculate this. Calculator में करेंगे, then it will be 9 multiplied with 10 raised to the power of 11 by 2. Sn is 11 divided by 2. ये आ जाएगा 2846 2.8. So FC maximum is coming out to be 2.8 megahertz. So this is the maximum frequency that can be reflected back. Okay, तो इसका मतलब ये नहीं हो पाएगी, ये नहीं हो पाएगी, ये नहीं हो पाएगी, सभी हो. So option A is correct. Alright. So question phenomenal by which So tell me the answer for this question. By which phenomena the light will travel in the optical cycle? So the correct option is total internal reflection. Okay, a conceptual question, but a good question. Conceptual, important. There are not much solving questions over here. Basically, most of them are conceptual questions. Course acceptance and a photo detector is made with a semiconductor, alright, and alright, so here we conclude this topic, alright, and in the next session we start a new. So all the best.